In this lesson, we are going to learn about linear inequalities. So this is like the second part of our unit here. We just learned about systems of equations by graphing, substitution, elimination, and now we're going to learn about linear inequalities. So instead of it being an equation, it's going to be an inequality. So first thing that we should do is take a little bit of notes. So a linear inequality is similar to an equation, but uses an inequality symbol instead. Now there are four inequality symbols: less than, greater than, less than or equal to, and greater than or equal to. The solution to a linear inequality would be all of the ordered pairs that make the inequality true. So linear inequalities are like linear equations. We can see them in slope-intercept form, standard form. We rarely will see them in point-slope form. But instead of seeing an equal sign, you're going to see one of the four inequality symbols. So 2x minus 3y equals 15 would be something we would deal with in the linear equations unit, but now we have 2x minus 3y is less than 15. What they're asking us to do here is determine which ordered pairs are solutions to the inequalities, and what we would do is just replace in the x value and the y value into the inequality to see that it is true or not true. So it is 2 times 2 minus 3 times 5 less than 15. Well, 2 times 2 is 4. And then this is going to be minus 15. And 4 minus 15 is negative 11. And negative 11 is less than 15. So this would be, yes, it's true. 2, 5 is a solution to a linear inequality. Now for a linear equation, there's only going to be one answer. But for an inequality, there can be several answers. And I'll explain why once we get to the graphing part. Next, we would just do the same thing again. Replace in negative 1 for x and negative 7 for y, and just calculate it out. Now this whole entire thing really can be done right in the calculator, but this is negative 2, this is positive 21, and negative 2 plus 21 is 19. 19 is not less than 15, so this would be no. Negative 1, negative 7 is not a solution. So I'm sure you kind of get the hang of this at this point. Replacing this in 2 times 3 minus 3 times negative 4. Is this less than 15? Well, this is 6. This is 12. 6 plus 12 is 18. 18 is not less than 15, so no. And then last, replacing zeros in, 2 times 0 minus 3 times 0. Is that less than 15? Well, this is 0, and 0 minus 0 is just 0. 0 is less than 15, so yes. So what we're doing is now graphing linear inequalities. So our process here is we're going to be taking these inequalities, we're going to be graphing them, one line. And then we're going to be taking next systems of inequalities, 2 lines, and graphing them. The only way to solve a linear inequality is through graphing. So unlike systems of equations, there's like graphing, elimination, substitution. Linear inequalities, there's only one way to solve, and it is through graphing. So when we're graphing linear inequalities, the first thing that we need to do is put the inequality in slope-intercept form. So that's step 1. Now don't forget, anytime you multiply or divide by a negative number with inequalities, you have to flip the inequality symbol's direction, just like we did back in the beginning of the year when we were learning about just solving inequalities in general. If you divide by -3 on both sides, you flip the sign. If you multiply both sides by -2, you flip the sign. If your answer ends up being negative, that does not mean you flip the sign. It's only if you're dividing or multiplying by a negative that the sign is going to flip direction. And then for the line, we're so used to just drawing regular lines, but there's actually two different types of lines. We use a solid line anytime the symbol is less than or equal to or greater than or equal to. And that is because a solid line means that every point on that line is a solution, and that's where this little equal to part of the symbol comes into play. Because if we're trying to find solutions that are less than or equal to the line, that means that all of the points on the line are solutions as well. But we use something called either a dotted, you'll hear me say either dotted or dashed line anytime the symbol is less than or greater than, which means that none of the points on the line are solutions because we're trying to figure out where the solutions are greater than the line, which means none of the points actually on the line are going to satisfy the inequality. What's different about graphing these is we actually have to shade a region on the graph. And anytime our symbols are above, so above would be like greater than or equal to or greater. This is above. Those symbols we can think of as greater than, more than. We're going to be shading above the line. And then below the line, we would be shading anytime the symbols are less than or equal to, or just less than in general, just like the less than symbol. So the first inequality that we're using is the same exact inequality from up top. But now we're going to be graphing it rather than just seeing which random points are solutions. So first thing we would have to do is put this in slope-intercept form, and I'm going to do that by subtracting 2x from both sides. We get -3y is less than -2x plus 15. And then when we divide everything by -3, just be very careful, we are dividing by a negative, the sign is going to flip. It's going to go from less than to greater than. It doesn't change the type that it is, it's just going to flip directions. So now we have -2x divided by -3, that's +2/3 x, and 15 divided by -3 is -5. So this is the inequality that we're going to be graphing. It's in slope-intercept form. We should still remember how to do this. Starting at -5 on the y-axis, 1, 2, 3, 4, 5, we're going to plot a point. And then from here, we're going to go up 2 and over 3. Now here's the thing. We have to remember that this symbol tells us two different things. It tells us what type of line it is, and because it's just a greater than symbol and it's not equal to as well, this is going to be a dotted or dashed line. And also the symbol is greater than, which means the shaded region is going to be colored in above the line. So the type of line is dotted and the shaded region is going to be above. So when we go to connect the points, it's going to feel kind of weird. Instead of connecting them with a just straight regular line, you're going to be actually like either putting dashes there, or if you would rather, I mean, I know this graph's kind of small, but you could also like use like dots as well instead of connecting it with a straight line. You'll see me probably use dashes instead of the dots, but sometimes I do dots if like I need to. So that is how you would show that none of the points on the line are solutions. And then the symbol is greater than. That means the solutions are all the ordered pairs above the line. Sometimes it's hard to tell what's above or below. Read the graph from left to right and imagine like standing on the line. Above the line would be anything above. So like literally shading it in just kind of looks like that when we do it by hand. If you really want to take your pencil and like shade it in really nicely, that's totally fine. But just like a scribble, so I know which area is the solution region, is perfectly fine. So doing a couple more problems to make sure that we're good. Number 1 is great because it's already ready to go, ready for us to graph. So we're going to start this at -5. So 1, 2, 3, 4, 5. And this has a slope of 1/3, so up 1 over 3. And we can kind of stop there if we want, or if we want to continue on with the pattern up 1/3, that's fine. And then we have to make sure we realize when we go to connect the line, we have to see the symbol and understand, okay, this symbol means it's going to be dotted or dashed, however you want to call it. And greater than means above the line. So when I connect these points, I'm going to connect them not with a solid line, but with a dashed line. And the solutions are above it. Now, if you're not really sure, well, how do we tell that it's above? Honestly, the easiest way is to just memorize, like greater than is above and less than is below. But if you want to mathematically show that it's definitely above, pick a point, any point. Usually 0, 0 is the easiest point to use. And what you would do is test that point. So if you test any point, I'm going to test the point 0, 0. I would basically take this inequality, replace 0 in for y and 0 in for x, and see if this is true or not. Well, 1/3 times 0 is just 0. 0 minus 5 is -5, so we're just going to get 0 is greater than -5. That's true. Because that's true, that means that 0, 0 is in the solution region, which verifies that all of the ordered pairs above the line are solutions. Now, do we have to do that every single time? No, but that is helpful. So that is how we graph linear inequalities. So really, you already have the skills to do this. It's just now applying this new thing of either solid or dotted lines, and is the shaded region above or below, which represents where all of the solutions are. Number 2 is also all ready for us to go in slope-intercept form. So we would just start this at -1 on the y-axis, and from here we're going down 2 over 1. Now this symbol has the equal to part, so this is going to be a regular solid line. So when we go down 2 over 1 and we connect our points, this is going to be a solid line rather than dotted or dashed. And then this also means the less than part of it means that it's going to be shaded below the line. Now this is where sometimes it gets confusing, well, what's above and what's below? It has nothing to do with where the negatives are, because on a graph, you can have negatives to the left, you have negatives below, so it actually has nothing to do with negative numbers whatsoever. You look at the graph kind of from left to right, and if you were standing on the line, like you would have no choice but to stand here. Like you wouldn't be able to stand on the other side of the line because you would just fall. So if we were standing here, then you can interpret it as where above and below the line. Above would be up here, below is down here. Everything underneath of this line would be the solution region. If you're not really positive, then what you would do is just test a point. So testing a point means pick any point that you want. 0, 0 is usually the easiest point to use. So if I was testing the point 0, 0, as long as it's not on the line, you can use it. But if I was going to test the point 0, 0, I would replace in 0 for y and 0 for x and see what happens. We're going to get 0 is less than or equal to -1. And that's not true. That's false. 0 is not smaller than -1. That means that the region that 0, 0 is, which is above the line, is not the solution region. Therefore, the region below it would be. So if you need to use that to help you, then that's totally fine. Now, of course, sometimes the problems are going to become more difficult, like number 3. We already saw a problem like this, but when you're going to graph these types, you will have to put them in slope-intercept form first before you can do anything else. So if we were doing this, we would first subtract 5x from both sides. Then we would divide everything by -2. We would get y is, don't forget, we're dividing by negative, so it's going to flip the sign, 5 over 2x, and then -6. We would start at -6, 1, 2, 3, 4, 5, 6, and then we're going up 5 and over 2. This is going to be a dashed line, so not going to graph it like a solid line like we're used to. and the solutions are less than the line. They're below the line. So below this line, if we're looking at this graph, if I was standing on the line, I'd have to stand over here, and below the line would be underneath of it. Now, I don't feel like we need to do every single practice problem because I feel like, you already know how to graph. The only thing that's new here is now the type of line and then shading above or below. I do want to remind you, though, that when we have problems like 7 and 8, these are when we have horizontal and vertical lines. So y is less than or equal to -4. I want to remind you this is a horizontal line. So at -4, we make a point. And this line is going to be solid because this symbol has the equal to part, so it's just going to be a regular solid line. And then anything less than or equal to -4 means anything underneath of -4 on the y-axis. So that would just be anything underneath of the line, less than the line, below the line. Number 8, we have x is greater than 7, so we go over to 7 on the x-axis, 3, 4, 5, 6, 7. And this is going to be a dashed or dotted line. The symbol does not have the equal to part. And anything greater than 7, this is going to be a, well, this is going to feel different because the line's vertical, but anything greater than 7 means any numbers that are greater than 7 on the x-axis, which would be to the right of the line, not to the left of the line, because all of those x values are less than 7. Now, what's cool about these problems is that Desmos can really help us out with doing the graphing part of this. So I did want to show you because we have Desmos that we can use, for us at this point in the game. If you need it to, you can. Now, this is the regular Desmos that you would just like desmos.com/graphing. This is what you would see. The Desmos graphing calculator that I have embedded in Schoology, I like you to use instead of this because actually this screen does do more stuff than what is available on the Keystone. So I don't want you to get used to like this one and then the Keystone gives you less stuff. But just to show you what I mean, if we do, let's say, number 4 together, number 4, we first would have to solve this out, so give me a second. Let's subtract x from both sides. -4y is less than -x plus 8. Divide everything by -4, and we get y is, careful, greater than +1/4 x minus 2. So this is what we're going to be graphing. So what's really nice about Desmos is you can basically have Desmos do the whole thing for you, and you can just kind of copy it on paper. And the Keystone, if the Keystone gives you a question like this, like why would we not use Desmos? And at this point, why would we not use it if we know we can't? We can, and I'm telling you, you can. So the inequality we would graph is y is greater than, so you just click the buttons, and then 1/4, and then click over, x minus 2, and then wow, look, it just gives us the whole entire thing. So we can see exactly, where the line is. We can see that it's dashed. We can see the solution region. It helps us identify some points we should put onto the graph. 0, -2, that's our y-intercept. They give us this other point, the x-intercept, 8, 0. So you can use that to help you graph, and you can kind of transfer it from online to paper if need be. So that is the lesson with linear inequalities, and you can use Desmos to help you. I mean, it's your choice if you feel like doing it by hand is quicker or using Desmos is quicker for you. I still want you to be able to do it and understand it because you're going to need it for, of course, Algebra 1, the Keystone, and you're going to need it for Algebra 2, but because we have this awesome technology, I also think that using Desmos to check your work or help you out in whatever fashion you want to, or however you want to use it, is totally fine.